All right, great, wonderful. Thank you so much. Good afternoon or good morning, depending on your time zone. Thank you so much for joining us. My name is Oliver Buchse. I'm with Thermal Energy HQ, and we want to share with you today an amazing product, our thermal tank, and some adjacent products. We have a couple of sections that we want to go over today. Who are we? We have our president, Garth Schultz, on the call. He will say a couple of words. We'll talk about our team. And then really comes the essential questions. What do we have that others do not have? And how can you as a client, or how can your clients benefit from that? Why would it make sense to partner? And we want to take your questions. And really, we are interested in your questions at any point. So feel free to interrupt me or put a question into chat. Bill will keep an eye on the chat. So let's start with who is Thermal Energy HQ, and I will let the man speak who invented the entire operation. Garth, if you wouldn't mind giving us a little bit of background on yourself and the company. Garth, are you on mute?
Oh, thanks. Nothing like being a mute. My name is Garth Schultz, president, founder, inventor of the equipment we'll review today. Started this venture, about 18 years ago, and was auditing, looking what was happening in the renewable space. And obviously today we'll review some things we did on the solar side, PVT modules. But in the coming wave of what was happening on energy storage, the tank came along many years ago, and now it seems to find a home and a fit for energy efficiency projects that are cropping up all over the world. So we look forward to today to discussing the designs, look forward to the questions, and if we can't answer them today, then we'll take them aside and individually look at your opportunities, and we enjoy the flow of discussion today. And as well, the guy beside me on the photo, Rob Canarans, he's my partner in the venture and located down in the Fort Lauderdale area. We're up here in Oxford, Michigan, and my background was automotive engineering. And so the emphasis, and we had a different look as to how to design things in the solar space and also here in the thermal energy space. But once again, look forward to the questions, and thank you for your attendance.
Great. Thank you so much, Garth. Here's a quick look at the team. Some of us are on the call, Graham, myself, Bill. We're a small company. We are small but mighty, and when you hear the story of our tank, you'll understand what I mean by that. So let's jump right into that. What do we have that others do not have? Domestic hot water is a commodity business. Excuse me, thermal tanks are a commodity, but Garth has truly reimagined what a thermal tank can be. And it boils down to this question: how can you fit a 700-gallon thermal tank through this 32-inch door? Now, the 32-inch door may seem a little exaggerated, but we encountered exactly that problem for a client very recently, and they had no option of doing that. So they had to put a bunch of small tanks through that door and then, kind of fit them together on the other side. So we have a solution, and we're going to show you a video in a moment. The thermal tank originally was an accessory to Garth's primary invention, the PVT, and we'll introduce the PVT a little bit later. And Garth invented the thermal tank on the basis that he couldn't get a larger tank through a small door. And that ultimately turned into this product and product series that you see today. We just created this little video. The video does a much better job than I could do in explaining the story, so I'm going to play it for you. If I can find the button here. Oops. There it is.
If you are involved in designing or installing domestic hot water systems for commercial properties, you have most certainly run into the following problem. You would love to use a larger thermal storage tank. Not only is it needed to meet the hot water demand of the building, but it also allows you to tap into several other advantages. It helps your existing source of energy run more efficiently. It can save you money by avoiding peak rate cycles and lower demand charges for monthly maximum power usage. It also increases the margin of error if the system is not operating perfectly. But there often is one big, or should we say, small, problem. The door to the mechanical room is too small to fit a larger tank through it. As a resourceful professional, you have always found a solution, combining multiple smaller tanks into an array. That, however, has been driving cost and system complexity up. You always knew it was not ideal, but the best option under the circumstances. That is, until now. Introducing the thermal tank. Available in sizes from 350 to 700 gallons on a 60-inch diameter, with larger versions coming soon. The thermal tank is one of a kind. It is modular in its design, which allows for easy transport to the site and assembly on site, even in tight mechanical rooms or other difficult to access spaces. It is made of lightweight materials. No individual component of the tank weighs more than 15 pounds. Anyone can carry them, and each one easily fits through even the smallest door. The tank is among the highest performing tanks in the industry, with R values ranging from R equals 18 to R equals 22, depending on size. Even our smallest commercial tank, the 350-gallon tank, loses less than 3.8 degrees Fahrenheit over 24 hours in free convection. The thermal tank also operates differently. Water is used as a thermal battery fluid, filled into the tank once and only moving within the tank and the connection to the heat source, such as a heat pump. We recommend water as storage medium for ease of operation, but other mixes are also possible. The optimal tank temperature is between 110 to 140 degrees Fahrenheit, but higher temps up to 180 degrees Fahrenheit can also be supported. The usage water on the load side is heated via a heat exchanger and never mixes with the tank water. The tank is unpressurized and can hold 55 kilowatt hours in the 350-gallon version. The thermal tank is made entirely of non-corrosive materials. The EPP walls, TPO surrounds, and PVC liners are eco-friendly in their production, with a more favorable ecological footprint than steel tanks. No bonded materials are used, and all component materials are 100% recyclable. The various design factors result in significantly lower cost to install, lower cost for maintenance, and substantial operating savings as described above. Should the tank ever need to be moved or disposed of, then it can be disassembled just as easily as it was assembled. In more advanced use cases, the thermal tank can also support heating and cooling applications. We even had clients use a tank farm in place of a large cistern. Lack of large thermal tank options was yesterday. The thermal tank is the answer for your next larger scale DHW system. Check out more details on thermalenergyhq.com or contact us at info@thermalenergyhq.com.
All right. So it always took me 20 to 30 minutes to tell that story, and now we have it in a compact 3.5-minute version. Are there any immediate questions that pop up as you watch this video? Okay, hearing none, then I assume we did a pretty good job. So we really want you to rethink what a thermal tank can be. It's not made from steel, it's modular, it's unpressurized, and it uses water as a working fluid. And then we have sort of the ancillary benefits of being recyclable, eco-friendly materials. This is truly a different concept in many ways. And Graham has coined sort of this multi-P logic for us: practicality, performance, price, and then we added planet-friendly into it. The practicality really goes back to the modularity, the ease of transport to the site, the lower cost of transport. You're not shipping air, easy install. We've had scenarios of having to put a tank on the roof of a hotel in Old Town San Juan. And if you had to put a steel tank up there, it doesn't fit through any elevators. You cannot bring it up the staircases. So you're talking about a crane, bringing a crane on site. Similarly, if you move other heavy equipment up on the roof, a crane is usually involved. In this case, we can move individual pieces up the service elevator and assemble them on site. Performance, Garth, correct me if I'm wrong, but to the best of my knowledge, the top competing products that we've seen out there are R14 insulated steel tanks. I have really not seen anything that's cracking the 20 as your product is. Is that correct?
You got Lochinvar and others. They advertise a unit, but it's a metal tank, but it's highly insulative. But the cost and performance and being able to put it into a small space, no.
Mm-hmm. Yep, and so that leads us to the price advantage. We'd be more than happy to give you quotes on different configurations. The rule of thumb is that on a sort of per gallon or per kilowatt hour of storage capacity, we have a significant price advantage over the competition. And the larger the tank gets, the greater that advantage becomes. And we've addressed the planet-friendly versions. We currently have 350, 500, and 700 gallon models. We have different heat exchangers that we can pair them with, different energy sources. And we're working on a 1,000 and 1,500 gallon option that prevents having to combine multiple tanks into a larger segment. And we are also introducing, in collaboration with a partner in Puerto Rico, our first residential product line. This came out of a conversation with that partner where we introduced the commercial product, and they said it's just too large for most of our clients. But if you had a smaller one, we'd be very interested. And lo and behold, Garth did have a concept and we refined it. So this is designed for a single household or even apartment. It allows the owner to take advantage of all the same design principles and operating principles that we just went over. The heat pump is not integrated into the tank by design, in contrast to some of the other heat pump water heaters that you see. And that allows you to place it in another segment of the home, of the apartment, capture that cooling benefit, or even move it outside. There's no ventilation required on the install. I mentioned earlier that our original product was the PVT. So Garth, I'm going to turn it over to you to give us a little bit of a rundown on what is the capability of the power panel PVT.
Thank you. Power panel PVT combines electrical generation and thermal capture in a single module. So there's, if you were to research and look out on market, there's several brands that are there, and predominantly all of an unglazed. They try to take a standard PV module, put a thermal capture mechanism on the back, but it's to low thermal output. This is a ground up design. And we have a properly flat plate glazed collector that at peak efficiency, last time I had it tested, client set in Israel is like 84% thermal efficient. You back the electricity off from that, and then you end up with a powerhouse of 1 part of electricity, 4 parts of thermal energy that you can go and do work with. So that's a product that's currently in our line, ICC, SRCC listed and certified.
Mm-hmm. And in the tank, as I mentioned earlier, does not care where the energy comes from. It can come from the heat pump, from the PVT. It could be, waste heat recovery systems. And in some installations, there is benefit to actually combining them. This is a little drawing here of an install from Bolongo Bay. Garth, what are some of the advantages that can be captured by combining these technologies?
Well, one, on the solar side, the electricity produced off of that device operates, a heat pump system on a net annual basis, so that you have no grid electrical usage per se. It balances out. So the thermal energy that's produced, and as you can see from the illustration, we store it in two 350-gallon tanks that's underneath the array on top of the roof. And then that acts as preheat that goes into a further set of 350-gallon tanks that are supported by a air source heat pump, so that final delivery into the hotel is maintained. That used to be the hotel's #1 complaint: no hot water. And then after this, no complaints of that sort, just the size of the showers, because it's a rather old establishment. So we're quite proud of that installation. Combines all the technologies that we had at hand in order to deliver a premium solution to the client.
All right. Garth, you mentioned earlier the energy capture mechanism. Maybe a word on this patented model here.
Thank you. Fluid we introduce at the top of the module, and it serpentines down through on the backside of our PV collection system in order to capture the thermal energy that would otherwise just go to waste. And then at the bottom, it either goes into the next row of modules or back to the thermal storage tank. And this is an all unpressurized, gravity-fed system. So very simple in its construction and architecture.
All right. And then to round out our product introduction, you're basically leveraging this drain back water cascade for a new application, a cooling application. Maybe just say a little bit about Sky Radiance.
In conjunction with 3M, who has a passive radiative cooling film, we've taken that film, and instead of putting PV cells and trying to capture thermal energy, the nature of that product is sheds energy. So by routing hot water through the module, it actually sheds it back to the atmosphere, the blackness of space, and convectively out to the atmosphere. And so that's a product that's underway, under test in conjunction with 3M.
All right. So key question is, how do our clients benefit? Let's talk through examples. We had one situation in New York, a residential apartment building, and New York has very strict decarbonization mandates. So if building owners in buildings over 50,000 square feet do not migrate away from fossil fuels, they face penalties in the future that make it almost prohibitive to stay with traditional heating systems. And they happen to have just installed a domestic hot water system with 4 120-gallon tanks. So they learned about our solution just too late, but it was not yet too late for their space heating approach. So this is where we coined that term of the 700-gallon tank fitting through the 32-inch door. And another client literally would be forced to take off their roof to replace or to bring in new steel tanks into where they have the domestic hot water system currently, and they were very relieved that we have an alternative for them that allows them to do that. So there are situations where no other install options are available, or the install options are very fragmented, lots of small tanks that need to be jerry-rigged together. Here's an example of a multi-family housing complex in California. Garth, you were closely involved with this project. The client is very happy. Tell us maybe a little bit about this original situation and how this relationship has developed since then.
Thank you. So Carbon Zero Build, and I think there's articles out on this particular installation. Their nature of the business is to take multi-tenant residential and refurb them. And in this process, we were introduced to us by a great engineering resource that we have out in California named Josh Plasted. And with that, came to the conclusion that our thermal tank is an ideal fit and solution into this space. So they, out there, if you're converting this and if you have the stack of incentives, you have to not leave any natural gas generating components left in there. So all those removed. So it's air source heat pumps, plus our thermal storage tank in order to service out this facility. And as a result, they've come back and repurchased. We've kind of been building that relationship, and we look to further that because their book of business and what they're doing aligns exactly with the properties and natures of what we have in the thermal storage tank.
Right. So they valued the simplicity of the install. I think one of their comments was it was the system came up more easily than any other commissioning they've ever gone through. And so now they're converting their pipeline to a large extent to this solution. Another angle here is really driving down the electrical bill. So there's a lot of nuances to this. What is the energy pricing in your local market? Are there time of use rate cycles? Are there demand charges? But just as an illustration here, if you have a delta between your nighttime electricity rate and your daytime rate, and we've used about a 3-to-1 ratio, we've seen far greater discrepancies in some markets and some tariffs. The ability to essentially charge the tank in off peak cycles and utilize the energy throughout the day results in a significant economic benefit. And then in those markets where the utilities are also charging demand charges, so for the highest amount drawn in a 15-minute window during any given month, there is that basically defines for how many kilowatts you need to pay extra. And so if you can avoid stacking on the electrical demand for the hot water system onto the residual demand of the building, it can also have a significant impact. And Garth is now going to walk you through in more detail a client situation where he has modeled this out in great detail. It is a client, a church actually, in White Plains, New York. And so Garth, I'm going to let you introduce the project a little bit and what you found when you did the research and the modeling.
So legacy at this church is they're heating through fuel oil. You can see the noted price, $3.20, $3.50 a gallon. And the opportunity, and it was really brought to us by Josh Heald of our team. And if anyone has projects that require financing, please reach out to us and we can connect you with Josh and hopefully our solutions as well. So looking at the energy usage of this church, they were just heating it. They weren't cooling it other than some through the window air conditioning. So you ended up with an ASHRAE base 68 heating and cooling load. And from that, could prescribe what you'd want in terms of air source heat pumps and our thermal storage in order to quantify what was going on in that facility. And by the curve shown on the slide, the red is the heating curve, and there's a little bit of hot water usage. They have in the church, they operate a school in the basement 5 days a week, a little bit of hand washing. So that's the line. And the blue is the space cooling requirement in the facility. And what makes this opportunity so attractive to anyone is you take a look at their on-peak versus off-peak energy costs. So they're being hit with almost 83 cents a kilowatt hour, 16 hours a day, 5 days a week. And for 8 hours at night and all the time on the weekend, energy is available at 13 cents a kilowatt hour. So that tells you if you were to put any in electrifying this, you want to electrify, but you want to go and capture that energy when the time tells you to. So for 8 hours a day, it's like, let's go make hay at a very cheap rate.
Right. And so Garth, you had shown earlier that the current rate was the equivalent of about 9 cents per kilowatt hour. So even the electrical off peak here would be higher, but then comes the coefficient of power of the heat pump paired with this that essentially requires a lower input load to begin with.
Yep, they take that COP of the heat pump and divide it into which one of the numbers, and that's going to tell you when you want to create your energy at your cheapest rate. And so the idea is we got to go and match the amount of thermal storage that's available on site so that they're working on the off-peak. a little bit of synthesis and analysis on the heating and then the cooling side, and what happens with 8 of our storage tanks versus 12 of the storage tanks, and how much benefit we can have to the system. So the site plan that's going to come up, there's plenty of room to package our solution, and it says, at 12 we can probably fully subscribe and tuck away their thermal energy requirement per day. And the way that this is set up is that you have air source heat pumps on the outside that are charging the tanks. The tanks are then in a twin pipe configuration into the church, and inside the church we have liquid to air heat pumps that, if required, can turn on in order to boost the temperature up to final delivery. But for most of the time, they're just going to be acting as radiators into the system. So it's a good interplay on how to kind of satisfy electrification of heat and using thermal storage for best benefit to the customer.
And Garth, obviously 8 or 12 tanks, that sounds like a huge number. Typically when we design domestic hot water systems only, it's a single tank or maybe 2 tanks. But once the space heating component on a large building comes into the picture, that number goes up significantly to be able to address the maximum loads in the heating season.
Yeah, at footprint, 36 square feet. You can see that where their campus is at the church. The building in red on the upper left hand, that's the church proper. Other kind of quoted solutions. You've had they had other potential suitors and solutions there. Some of them being the mini splits, and that was rejected. And it was even a higher cost than what we quoted, but they look like tombstones around surrounding the church with those little mini splits. We can be off the church proper at a place that they're calling Davidson Hall, and put our assets in there, and through the pipes that originally carried the hot boiler fluid, for heating the church, is our thermal communication into the building.
Okay.
I think there's a question that came up. Someone came up, hand raised. If that wanted to get answered, we can certainly entertain that or do it at the end.
No, let's take it now.
Okay. I think Sala was answering. So what was the question, Bill?
It's from my experience from Sala, working with thermal storage, I've seen both water-based tanks and PCM solutions used in different cases. In certain scenarios, PCM appears to provide improved efficiency and economic benefits. Have you personally implemented PCM-based thermal storage in real projects? And if so, in what type of applications?
Yeah, PCMs, we're looking at them, but in this application, so you can imagine, and it'll come into the next chart, you want to be able to store, phase change materials. They got a narrow window in which they would want to charge and then discharge in. And in our application, because we want to take this throughout the heating and cooling season, you'd have to have a phase change material that would work in both realms of heating. At a higher temperature exotherm, and then at a lower temperature display. And as you can see from the chart, during the wintertime and using liquid, we're storing hot water, and then you come into the shoulder seasons of late spring, and sometime during the day you want space heating in the morning and then space cooling in the afternoon. And we can set up the tank farm with controls and valving so that at night, during that 8-hour period, when you can go and make energy, so you can make some hot, you can make some cold, and address the facility throughout. And then, of course, in the summertime, all space cooling, you're going to be banking, chilled water or cold water, to feed the liquid to air heat pumps that are within the facility. And back into the fall season, once again, you want, both energies available to you. And then in the winter where we're at right now, it's all space cooling.
All right. Peter, you
had your hand raised.
Yes, I did. I'm going to jump on camera for a minute. I apologize in advance. I just moved. Garth, how are you, my friend? Good to see you.
Good. How about yourself?
Very well. So I'm real familiar with Garth and the products for 7-8 years now, and I'm down in South Florida now, and I've got a good friend in the HVAC business, and your tanks, it just sounds like the market's caught up to you finally, Garth, because you're pretty far ahead of the curve. So would you just go over what's your ideas and thoughts on some larger tanks and the future you think for storage? I'm gonna jump off here after that. Thanks, Garth.
So as Oliver described, we have a 1,500-gallon tank, 1,500 gallon footprint that's going to be available here probably in Q3, late Q2. We're starting to kick off the tooling, and its energy storage capabilities. Boy, you're at over 200 kilowatt hours in the 1,500 gallon tank. So you can imagine if people are starting to talk, well, I need a megawatt hour worth of storage, it's going to be 5 of those tanks linked together. So you can get to that size and authority pretty quick in order to address more larger commercial and industrial applications.
Great, Garth. I appreciate it. And we know this to be true because we know your data. So thanks again, Garth.
Thanks, Peter.
All right. Any other questions at this point? All right, good. So why partner with our company? Number one, unique product. There is a collapsible tank out in the market, but there's no other modular tank that has comparable performance characteristics. We also received our UL listing, so that's another aspect. So this product can truly solve client problems that simply cannot be solved by other tanks. The competing solutions are usually cumbersome and very costly. We are very hands-on, willing to go on site. We are not a pure manufacturer, buy it, take it or leave it. Garth, Josh Plaisted are deeply engaged with our clients. We are offering staff education for your teams. We can do dedicated webinars such as the one today. We have distribution partners now in Puerto Rico. We're about to go down for a very detailed training program. And we love the creative problem solving. Show us one of your problems. Let us help you dig into it and see how our solution can address that. And there is a first mover advantage. By being the first to really be able to bring this to a geography, bring it to your clients. In the beginning, there's usually a little bit of convincing work needed. Some contractors have never seen this before, are reluctant, would prefer to stay with a steel tank. But once it gets spec'd or an engineering firm says, we're going to give this a try, the repeat rate, as we've seen with our client in California, is extremely high because they love the tank on that basis. If you're looking for an opportunity to see the tank in person, we will be in Las Vegas with a life-size walk-in tank, actually. The first time we're creating one of those. You can walk into the tank and admire it from the inside. But we're also available anytime to answer your questions, create a custom webinar for you. If you're in California or in the New York area, we have reference projects on the ground. One is coming up in Florida right now. We have one in Cleveland, Michigan, so various opportunities to see this live. With that, we do have time for questions or comments. Any thoughts? What other questions can we answer for you?
Hey guys, it's Graham here. I wanted to throw in just one adder, which I've experienced, and I think it's going to become an increasing problem that we solve, and that is the fire marshal's aversion to having lithium in buildings. Using this as a energy storage as a battery and playing the arbitrage game allows you to basically compete with a lithium battery in that arbitrage game for a fraction of the cost. And that applies back to that apartment building you were looking at in New York. The fire marshal's not allowing lithium in the building, so they got to put in heat pumps, and they get more exposed to these these demand charges and the escalation.
Excellent point. Thank you, Graham. All right. I'm taking one last call for questions. All right, hearing none. Thank you all for joining us today. If you have any follow-up questions, if you would like access to any of our materials, spec sheets, please reach out. You can reach us at info@thermalenergyhq.com. Was there a question? Okay.
And I just want to say to Sala, we can follow up on the phase change and which path. I probably broad brushed that pretty quick, but to converse with you and we'll dive into some details and convince ourselves one way or the other what the best path is.
All right. Excellent. Thanks everybody for joining us today. Have a wonderful day.
Thank you.